Today we discuss EM waves in conducting media. So inside the conductor we know rho equal to 0. So the Maxwell equations will be first grad dot E equal to 0, grad dot B equal to 0. Number 3, curl of E equal to minus del B del T. Number 4, curl of V equal to mu GF plus JD. So these are the four Maxwell equations inside the conducting media. Now if we construct the wave equation, then wave equation now similarly we at first take curl of the third Maxwell equation, then we get curl of E equal to minus del T of curl of V. From this we get grad square E equal to del T of mu sigma E plus mu epsilon del E del T. So the equation will be grad square E minus mu sigma del E del T minus mu epsilon del square E del T square equal to 0. These are the wave equation. This is the wave equation for electric field, and similar for magnetic field. It will be grad square V equal to mu sigma del V del T plus mu epsilon del square V del T square. Now we see the solution of this wave equation. The solution of the wave equation in the conducting media will be like this, look like this. For electric field it will be E equal to E0 exponential I alpha dot R minus omega T into exponential minus beta R, and V equals to B0 exponential I alpha dot R minus omega T exponential minus beta R. Here the propagation vector K will be alpha plus I beta. So in the conducting media or inside the conductor, the propagation vector K will be always complex number, where alpha will be the propagation constant and beta will be attenuation constant. Now if we want to find the phase velocity of the wave, then it will be Vp equal to omega by alpha. Alpha will be omega into root over mu epsilon by 2 into root over 1 plus sigma by omega epsilon the whole square plus 1 to the power half, and beta will be omega root over of mu epsilon by 2 into 1 plus sigma by omega epsilon the whole square minus 1 to the power half. Now we find the skin depth. What is skin depth? It is a distance where the amplitude of the wave decreases by a factor 1 by e. Skin depth, it is a distance inside the conductor. Distance inside the conductor for which the amplitude of EM wave decrease by a factor 1 by e. So in this conducting media, the skin depth will be as written as delta equal to 1 by beta. Now we find the skin depth for a good conductor and bad conductor. For good conductor, sigma by omega epsilon 0 always greater than equal to 1. Then alpha equal to beta equal to omega root over mu epsilon by 2 into root over of sigma by omega epsilon, which is equals to root over sigma mu omega by 2. So skin depth delta equal to 1 by beta equal to root over 2 by mu sigma omega. This is for good conductor. Now for bad conductor. Sigma by omega epsilon less than equal to 1. Then we get beta equal to omega root mu epsilon by 2 into 1 plus half into sigma by omega epsilon square minus 1 to the power half equals to omega into mu epsilon by 2 into 1 by root 2 sigma by omega epsilon, which is equal to sigma by 2 root over of mu by SL. So skin depth will be 2 by sigma root over of epsilon by mu. This is for bad conductor. And the phase velocity for the good conductor will be omega by alpha, which is equal to omega into root over 2 by sigma mu omega, root over 2 omega by sigma mu. This is for good conductor. In conductor, the magnetic field V always lag behind electric field E. And the phase we calculated, the phase phi equal to tan inverse beta by alpha or half tan inverse sigma by omega epsilon. And here also propagation vector K, electric field and magnetic field always mutually perpendicular, and also pointing vector parallel to propagation vector. Wave impedance equal to Z equal to E by H. This is equal to Z0 to the power minus I phi.